All right, today we're diving deep into one of the most mind-bending, elegant ideas in all of physics, string theory. It's this incredible idea that our entire universe might just be a cosmic symphony. So, let's start with this one wild question. What if everything you see around you, the stars, the planet, even you, isn't made of tiny little dots, but of tiny, vibrating strings? And what if those vibrations are creating the music that we call reality? Yeah, it's a big idea. Let's get into it. So to really get why we'd even need a theory as out there as string theory, you first have to understand the biggest problem in physics today. There's this massive split, a huge divide in how we actually see the universe. You see, the 20th century gave us two of the most successful theories ever. Each one is a total masterpiece at describing its own slice of reality. The only problem? They absolutely refuse to work together. Okay, so on one side, you've got Einstein's general relativity. This is the theory for all the big stuff: planets, stars, galaxies, the smooth fabric of space-time. It's all about gravity. Then, on the other side, you have quantum mechanics. This is the rulebook for the tiny, bizarre world of atoms and particles. It's chaotic, it's weird, it's based on probability. And here's the kicker. They're both right. They've been tested again and again, but they describe the exact same universe using totally contradictory rules. So what happens when you need both at the same time? Think about the very center of a black hole. It's incredibly massive, so you need general relativity, but it's also infinitesimally small, so you need quantum mechanics. And when you try to put their equations together, the math just breaks. It spits out gibberish, infinities. Physics just grinds to a halt.
And this is where string theory walks onto the stage. It comes in with this radical but incredibly elegant solution to finally bridge that gap. The main idea is actually pretty simple to grasp. Forever, we've thought that if you zoom in far enough on an electron or a quark, you'd just find a little dimensionless point. String theory says, no, not quite. It suggests that if you could zoom in way, way further, you'd see that they're not points at all. They're tiny, one-dimensional, vibrating loops of pure energy. Little strings.
Now here's where the magic happens. Instead of having a whole zoo of different fundamental particles, string theory says there's just one fundamental ingredient: the string. Every single particle we've ever found, an electron, a photon, a quark, is just the same string vibrating in a different way. It's like a guitar string. A C note and a G note are the same string, just vibrating at different frequencies. Same idea here. An electron is one note, a photon is another. And what that means is absolutely profound. All the incredible diversity in our universe, all the matter and forces, it all comes down to the different notes these tiny strings can play. The laws of physics become the rules of harmony. The entire universe, a cosmic symphony. But for this beautiful music to actually work, for the math to not fall apart, the theory asks for something pretty huge. It needs a universe that's much bigger and much weirder than the one we thought we lived in. 10. That's the number. For string theory to be mathematically consistent, it requires 10 dimensions of space-time. Not our familiar 4, but 10.
So, you're probably wondering, where are they? Well, we all know the first 4, right? You've got length, width, and height, the 3 dimensions of space, plus the 4th dimension, time. String theory says, yeah, we've got those, but there are also 6 more spatial dimensions that are completely hidden from us.
And the reason we can't see them is that they're curled up on a scale that is just impossibly small. Think about it like this. Imagine looking at a telephone wire from a mile away. It just looks like a one-dimensional line. But if you were an ant walking on it, you'd know there's a second dimension, right? The part you can walk around. These 6 extra dimensions are like that. They're just curled up so tight, trillions of times smaller than an atom, that we can't perceive them at all.
But the story doesn't stop there. The theory kept evolving, and as it did, it started to reveal even more mind-blowing possibilities, like, say, the existence of other universes.
You see, back in the early days, physicists ran into a bit of a snag. They were trying to find the one single theory of everything, but instead, they found 5. 5 different, competing, but perfectly valid versions of string theory. There was type 1,
type 2A, type 2B, and 2 different heterotic theories. And for a theory that's supposed to unify everything, having 5 different versions is, you know, not exactly ideal. It kind of defeats the purpose, right? But then, right in the middle of the 90s, something incredible happened. A new way of thinking emerged that suggested these 5 theories weren't enemies at all. In fact, they were all part of something much, much bigger.
And that something is called M theory. People joke that the M stands for mystery, magic, or even mother. What it really does is propose an even more fundamental 11-dimensional theory that shows the 5-string theories were just different snapshots of the same underlying reality. M theory also introduces these things called brains. Think of them as membranes, but in higher dimensions. The idea is that our entire universe could be a single brain, just floating in a higher dimensional space. And if that's true, there could be other universes on other brains floating right next to ours, a multiverse. This bigger picture also offers some really clever solutions to other deep problems, like the famous black hole information paradox. Okay, so what we have is this absolutely gorgeous mathematical framework. It connects everything, it turns particles into music, it hints at other universes. I mean, it's amazing. But there's one really, really big catch.
Is any of this real? Have we proven it? And the honest answer, at least right now, is a simple, straightforward no. And that's the biggest challenge the theory faces.
The problem is all about scale. These strings, if they exist, are thought to be around the Planck length. That's a billionth of a trillionth of a trillionth of a centimeter. We just don't have any technology even remotely powerful enough to see something that small directly. So instead, scientists are hunting for indirect clues. Maybe a faint signature left over in the radiation from the Big Bang, or tiny fluctuations in gravity. Anything that could tell us we're on the right track.
And yet physicists haven't given up on it. And the reason is because it's just so powerful, so mathematically beautiful. It paints this picture, as physicist Brian Greene says, of the universe as this grand musical instrument, where the strings are vibrating and creating the very tune that we call reality.
So string theory is still very much a work in progress. It might turn out to be the ultimate theory of everything, or it could just be a beautiful idea that leads nowhere. But it forces us to ask this incredible question. After looking up at the sky for thousands of years, are we finally starting to learn how to hear its music?